Okay, so hello everyone. Today we are moving to another part of the AI class. So as you remember, we were like closing the first part, let me say, of all basic statistical computation, probabilities, and like typical AI problems like search problems and gaming. Now we are going to move to, let me call it, a more advanced level, which is coming next even in the history of AI, which is a subfield of AI. In particular, now I'm talking about machine learning. But before discussing details about machine learning, let's consider learning like machine learning, deep learning, reinforcement learning in the same set, which is the set of learning. So the evolution now is coming from like probabilities, from statistical values that we are counting given a limited search space towards learning. And what does learning means for you? What comes to your brain when we talk about learning? Information. So you are right. Last time we were already discussing about information. What comes before information that we discussed last time? Data. So last time we were saying that the world is full of data. And when I'm saying data, I was taking the example of this element. I'm almost taking the same example. So if you just close your eyes and open, you see this. It's something, okay? It's black, it has some shape, it has some characteristics. So this is just data. This is a chair. Now you are knowing what is this data. So you have additional information. This is a black chair. This is a comfortable one. So this is now from data to information. And then from information, what we want. We don't want, not only don't want to recognize things or to know things, we want to make it useful, this information. So how to make it useful? Is that what we already said, that to take decision. Okay, so it's all about turning data into information and information into insights. And insights are what are going to drive this world. It's driven by decision taken, thanks, for example, to AI, to humans, and this is what we want. We don't want just to have information. It's everywhere now. Search like engines, for example, Google, even the GPT now, learning is there. Information is everywhere, like we say. But the way you learn, the way you profit from that information, it's not only that you are reading and going through information. No, it's how you apply that, how we can see the difference, what changes it brings to the table. Okay, so I want, for example, to see if you know something, it's impacting your behavior, for example. And what we want is to make, for example, better environment, better humans to go forward. Okay, so this is just an introduction to the topic, and now we are going to dive in details. So I am aware that some of you are already getting the machine learning class. So we are going to have like discussion. I know the AI class was a little bit hard for you to follow and all, but this would make it like we take some rest. For those who are exploring machine learning for the first time, it will be fun. So don't worry. And I would like really to exchange ideas, to discuss. If you have any knowledge, never hesitate to share with everyone, okay? So what we will do today is that what we are going to start from what we already seen so far. So far, we studied like in the introduction to AI, what we seen. We've seen the search problems, for example. And in search problem in particular, we went through different search algorithms. We went, for example, we see the DFS, the BFS, the A star, or whatever. All this, the main objective was what? It was to solve a search problem, given a search, like a search space, okay? So what difference between one algorithm and the other one? The difference was in terms of performance. And to evaluate the performance, we were seeing some metrics, like, for example, the complexity of the algorithm, the space complexity, the time complexity, and so on, okay? Now, how to decide which is the best algorithm now? It's better on this performance. And what we are looking for, and everyone is looking for, is the best algo, because I won't waste my time using all algorithms to like say which one. So we know that each algorithm is good for a given like problem, but what we are looking for is the optimal solution, whatever the algorithm, okay? So we want, for example, to reach from the initial state to the goal, to go through the shortest path, let's say. In other scenario, we want to have the least cost, okay? So these are examples of search problems. In more like advanced steps, before the Bayesian networks over time, let's discuss the Bayesian networks. At this level, what we were focusing on, we focused on uncertainty. Means if I have, we were discussing last time about random variables. So if I have a set of variables and there is dependencies between the variables, which what we were discussing is the conditional probabilities, for example. So some like facts is due to some probable other facts. It could be this or that or another possibility. So it's a huge space. Still, we were able to model that. Still, we were able to like make inferences based on that. And this is all thanks to the probabilities computation, because each time we had different mathematical expression, but at the end, what we did was all about probability computing, okay? So starting from this is the foundation, okay? If you are good at probabilities, you are good at mathematics, now you are already good with the AI class. What will happen is that when we are moving towards learning methods, and why you are maybe next getting special classes for machine learning. Maybe you may dive deeper into deep learning, for example, because these like kind of subfields, let me call them, of AI, they are there to address larger space, because you cannot keep checking all the possibilities. You cannot like keep mentioning all possible random variables, trying to make connections. The space is going to be that much huge, and how many resources you are going to use, how many probability values you are going to use, how many theorems you are going to apply. So this is a serious problem, and which is reflecting the real world problems, okay? So in this case, exhaustive models, they are not enough, and this is what we already seen, okay? So what we need is, it's not enough to use the fixed probability. It's not enough to keep doing this. What we need sometimes, or at some given points, is to use data, to profit from this available information, let me say data, okay, to make, for example, predictions, or to explore patterns, for example. So the key idea here is to learn from examples. And whenever we are talking about deep learning, let me say, I always say it's like having a new baby. Your model or your algorithm is a newborn baby, okay? So as a baby or as a human, how we learn? I keep seeing this world. Okay, we cry at first, but at the end, I keep checking things. After that, I keep learning, seeing a thing, like something many times would help me learn what is that, or it's going to put me in some conscious level that I will be aware if there is that thing straight. I'll say that's a chair. I would sit or not. So this is what a human does. So AI is going to perform, we are trying to make it act like human, okay? So at this level, we want to profit from the existing amount of data rather than explicitly coding rules or probabilities, okay? Because what we did before is we were like, it's all about computation, okay? We were finding the probabilities. We are like hard coding, I would say, like saying, if this will happen, then I will go on this path. If I'm in this path, then this is, because of this probability, I'm going here. So it's all based on such algorithms. So this is what we like statistical. When we talk about statistics, you know that it brings to the table probabilities and many mathematical background. So statistical learning now, it's a very important point, what we are going to just go through today before like introducing machine learning, because you need to have this mapping between statistics and machine learning. For the statistical learning, which comes in the middle now, it's a process, or it's a way to focus on making predictions. And if you are going to say, now we are going to change the words. Before we were talking about inference, okay? So inference or predictions, what we are going to to use now, we are going to use the word prediction more than inference from the existing data, using or exploring the relationship between the different input variables, or let me call them the features, we are going to focus with this later, and the output variables, which are the targets. So don't worry if you're not understanding some keywords, we'll cover that. Now, how it's going to be, this is using the probability theory that we were discussing so far, as well as the statistical inference in order to estimate the unknown relationship between variables. Now, from this, we go to machine learning. Between machine learning and like statistical learning, there is no gap. There is that intersection that makes machine learning at some point be seen as a statistical learning method, okay? So the machine learning here, it's a broader field that already includes the statistical learning, but it also covers like larger applications. It includes, for example, the methods coming from computer science. So if you focus with statistical learning, it's if you have that method, like let's take the example of Cole here with us. So Cole is coming with a mathematical background. Let's take the example of Farah, for example, in-person students. She's coming from a computer science background. So machine learning, it's where mathematicians and like computer scientists meet, okay? And they're already sitting on the same table. I'm so happy to see this. So there are many examples of machine learning algorithms. Some of them you may know, some of them we are going to explore, and let's not focus on that for now. Let's come back to the first introductory class when we were introducing AI and things like subfields of AI, machine learning, and deep learning. So when we talk about AI, we said it's like about programming things. I have a set of rules. And here maybe there is something called, I'm not sure if you get this class or not, what was that? Prolog. It's like a programming language, same as MATLAB or Python. So this is a programming language which is designed to program rules. If this, then this. And so this is a really strong, and I remember I had a class especially about this. It's called declarative programming. Okay, so each point in AI could be taught even as a separate module. Okay, but let's try to put everything together, like to see the bigger image, okay? So if already now AI, it's about programming things, preparing a program that is a little bit similar to a human, and we were calling that an agent, an intelligent agent, where the agent is having the ability to sense, to reason, to act and adapt, okay? If all this is there, so there is AI system. Next now, subfield of AI is the machine learning. And in machine learning, we are not programming, we're programming algorithms. And you know, an algorithm is like how to make, for example, an omelet. I don't know, I bring 3 eggs, then I put some salt, then I put some black pepper, and then I mix everything together, then I switch on. So saying this, that, then 1, 2, 3, this order is an algorithm. So everyone here must not say that I hate algorithms. I hate to write an algorithm, because our daily life, it's an algorithm. So every day we wake up in the morning, I don't know, I do my morning routine, I do some stuff specific based on that day, I come to the office, I prepare this, I do that. So this is the algorithm, okay? Are the steps that we are taking, okay? Now, this algorithm is not just about different known steps in machine learning. We say that we are introducing the word learning, which is bringing to the table data. So this algorithm is going to perform in order to improve the more that it is exposed to data over time, okay? And in life, it's the same. The more we see things, the more we learn. So this is the machine learning algorithm. The more you are going to feed data, the more this algorithm is going to learn, okay? Then a subfield is deep learning. And here, the difference is, let me say, in coding. Because there you are coding the algorithm. You are writing the steps. But in deep learning, there is like a set of architectures. And these architectures are designed specially to look like, let me say, human, to mimic the way a human brain, for example, is designed, or human neurons like function. And these algorithms I made to extract features and to learn from that features. Okay, so you see how the evolution is from AI to machine learning and then to deep learning. Okay, now what will happen is that we are going to start with the definition of machine learning. We are going to go through a set of definitions that I'm selecting. So 55 is coming with a machine learning definition that's saying it is a field of study that gives computers the ability to learn without being explicitly programmed, which is now making a transition between AI when we are giving an explicit like set of rules to the computer. Now it's going to just break this typical way of leading or programming computers to say that the computer now is not anywhere explicitly like programmed, somehow implicit way. There is an implicit way that computers are going to learn, and for sure from data. So this is a very basic, showing the transition from AI to ML. Another definition that I love from Herbert. So this is like, this person was winning the Turing Award in 1975 and the Nobel Prize in Economics in 1978. So here I find it more like real. We are approaching to the what is machine learning. So it is like he's saying that it's learning is any process by which a system improves performance over experience, which makes sense. Here we are at the level of defining what is learning, because in machine learning, the word machine is clear for everyone. Now the learning part, it's a process, and this process is going for what? For which reason? For improving the performance while exposed to more data, which is the definition that we started from. So machine learning is concerned with computers' programs that automatically improve their performance through experience. So there is the word experience, the word data, there is the word performance. So all this is mandatory to have an accurate definition. The last definition that is really like final one, which is by Mr. Tom in 1997. So a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience E. So which shows the same thing but with an example. And what we love is we give an abstract idea, let's illustrate it with example. So this is an example that I was preparing for you. So we have a set of like symbols, for example, T for task, P for performance measure, and E for experience, okay? Now, 3 examples. The first one, our task is playing checkers, for example. What is the performance measure in this case? It is the percentage of games won against an arbitrary opponent, okay? And what is the experience here? It's the more you play and practice, the more that you have chances to win, okay? Next, we have the example of the task of recognizing handwritten word, and we are going to perform such tasks given the data set that we would see later, which is the MNIST data set. So how to evaluate this? A performance metric here is the percentage of words correctly classified. So if I will give you a set of words, you are correctly classifying all of them, so your score or performance is 100%. And the database of human labeled images of handwritten words is the experience that you are going to have. It's what we will see later, we'll call training data, okay? I will start throwing some words to find you like later ready for that. Another one, it's the case of, or the task of driving on 4-lane highway using vision sensors. In this case, our performance metric is the average distance traveled before a human judged error. And our experience is a sequence of images and steering commands recorded while observing a human driver, okay? So I think it's making it more clear, and the experience in this case is shown like data that we're going to have. We have training data, and then there is a task given that data. That task is after that evaluated, given like the behavior or that is shown at each example, and the performance is, let's say, the true, like how many true positives I have, for example. Okay, we will see many performance measures, but let's make it simple for now. Okay, so for online students, is that clear?
Yeah, that makes sense. I have a quick question about like, what about a machine learning algorithm that it faces more data, but it gets worse with time? Because none of these definitions like take that into account if it gets worse.
Yeah, so Zoya, these definitions of machine learning we are studying now, this is the recent one. It's 1997. But if we come back in time, this one is 1959. So you can imagine if I am going to say huge data. I know what means huge data today, but huge data in 1959, it's a joke for today. So we need to be like aware of this, of the context of the definition, because when this definition of ML that we are going to start from, that they are the basic like block were there was a given setting, a given space. So we need to respect that. Next, we are sure that there is this problem. The space is getting like moving on higher dimensions, and this why the deep learning is coming. And then deep learning is not enough. Within deep learning, there is just GPU training, and there is like we are using more resources. You understand that? And optimization techniques are also like really evolved. So what we will say for now, these basic like definitions for the experience which is large, today we will consider, okay, to be clear and honest, it's larger than the context that we were studying for search problems, because at the end, the space is still limited. At that time, I was saying it's huge space, but if I would see it with the computational like abilities that we have today, it's limited. It's not enough for the space which is more large. So let me say more large, now it's the machine learning. Extremely large, we are going to check for the deep learning. So it's like small, medium, large, and XL. Let's treat it like that. We are just moving from the S to the medium or large, okay? So this is a machine learning. Is that clear, Zoya?
That makes sense, and I really like that analogy.
Okay. So we are going through these definitions. Any questions from other students online? Okay, in person? Okay, so machine learning now is programming computers to optimize performance criterion using example data or past experience. So this is clear for now, right? No, it's not clear, because to optimize itself, it's a huge field. I can say it's still unclear for me, because the more you read about optimization techniques, the more you will recognize that you don't know anything about optimization, okay? But to make it simple now, let's think of a problem. And if we are having a problem, we can for sure have a visual representation for that. Okay, let's suppose that any problem that we are having, whether it is represented by, we always have the time factor. I'll always present things in the 2D space, okay? So where I have my time, and through time, my performance. And at some points, when we talk about the performance, it's like we are, how much could be the best you can give in the exam? 110, my class, but it's usually 100, okay? So it's 100. So your effort for everything in this life is 100. This is coming from probability. So it's always 100%, which is 1. The sum of your all efforts cannot be more than 1. Okay? But your girlfriends want it to be 200% most of the time. So now, if I'm talking about, this is not clear. So now if I'm talking about performance, I am saying given a score or max score, which is 100. If I'm saying 100 is coming from where? It's coming from number 1, which is the maximum probability that could ever be, okay? Now, if I am going to decide, and we were already now exposed to the fuzzy logics thanks to Zoya. Now, who is taking the exam? I think no one. Yeah, I'm sure that last day, last minute, last second, I will receive many emails that, oh, the time I will, okay, let's discuss that later. But let's suppose that I took the exam. I didn't got 100%. How much I could get? For example, 90%. Okay, let's say that. I must have like a mistake in the A-star algorithm exam. So 90%. Now, to measure my performance in the exam, is this a complete information given the fuzzy logics? I succeeded with 100, with 90% percentage. This is the success. But
I failed with 10%.
always brilliant students don't say that I got 90%. I lost 10 points, for example. You got it? So we don't always look to the half of the cup which is full. Like Zoya was teaching us, you can see the empty face, for example. Okay, so there is 10% which is failure. So for both now, these are the metric, the final metric of my performance. It's not only that the success. So because to get that 100, there is a percentage for success, a percentage for failure. So the percentage for failure in machine learning or deep learning, we are going to call that error. Okay? Okay. Okay. The biggest error that could face you. So now, if we want to evaluate the performance now, I don't know why the people who are doing machine learning, they don't want to focus on success criteria, they focus on failure. It's complementary like performance. But now, whenever we are going to talk about the evaluation, we are going to represent the curve of the error, okay? So if I want to represent any given curve, what are possible like representations that I may have? Whether I would have a line, means it's a stable error that I'm going to make during my life, let's say, or for a given problem, okay? I want to make a error. But it could forever stay like stable? No. So sometimes there are ups, there are downs, there are... Okay, there are many problems. So, but let's zoom on, for example, a representation like this, where the problem is what we call is convex. Okay, so what we will have here, the curve, it's having, there is a direction, okay? The curve is first, the error is first decreasing. So supposing that I'm first time taking the review exam, maybe I am having 100% error. I'm not revising anything, which is very normal. Then I'm trying to get some help. Then the error is decreasing. Now, the day of the exam, everyone is going to do his best. So we are supposed to be at the optimal solution. After 10 years, if I will give you the same exam, you will again have 100% like error, which makes sense. Okay, so this is an example. So whatever I always represent with a continuous line is really a set of discrete points. Okay, so given now this problem, which is my optimal solution? Where it's when my error is minimum. And all machine learning, deep learning about optimizing the solution for finding the best algorithm, let's say. Okay, so this is an example of optimization. I wish now I'm making it a little bit clear for you. Okay, it's clear for everyone? Great. Now we are understanding machine learning is programming computers to optimize a performance criterion. The criterion could be like illustrated here, the error, for example, using example data or past experience. Okay, now there is a role of statistics here, which is the inference, okay, from a sample, and there is a role brought like thanks to the computer scientist, which is the efficient algorithms to solve the optimization problem, representing and evaluating the model for inference. Okay, now let's illustrate things. Okay, machine learning, if we compare it now to the traditional approaches, what is the difference? The traditional approaches, all the time we're having a problem, okay? And all the time we are studying this problem. In the traditional approaches, we are like using rules, like I was saying. So each time we're having a problem, we are writing rules. And based on rules, there is an evaluation. The evaluation could take you to the best solution, expected one, let me say. And the evaluation could also give wrong results, let's say. And this would let you analyze the error and again keep studying the problem, updating your set of rules, and it's a loop until finding the best results. This is the typical not machine learning, typical approach, traditional approach. Still, we are not talking about machine learning. So whenever we talk about AI, now you are able to say there is a very old, let me say, typical approach, which is based on rules. Okay? Now, moving to the machine learning, we are introducing or bringing to the table data. And data now is used, not like before, to write rules. No, we are not at this level anymore. So the data is used to train a machine learning algorithm. Now, once my algorithm is trained, I am again going to evaluate if all okay. Okay, otherwise we keep analyzing the error and learn. Okay, this is the learning process. There is a difference now, which is clear. Now, the key difference that I may say, one of them use rules, one of them relies on data, and while relying on data, we are developing an algorithm. Again, there is a difference between machine learning and the traditional programming, which could be seen here. If we have the case of traditional programming, our input, I have data, which is just like an input for now. And I have a program, and based on traditional programming, this program, I am going to give you an output. The second example, which is machine learning, which is going to take the output from traditional programming, which what we were thinking is, wow, it's the output of traditional programming. It's just the input for machine learning, okay? Add to that data as input, and we are going to have, instead of the typical output, a program, a powerful program, okay? Is this clear? No.
Yeah, that makes sense.
Yeah, it makes sense, but I would illustrate it with an example for sure. I cannot let you. Okay, you can sleep, guys. I don't want you to feel my class is boring, but I want to make sure that everything is clear. Okay, one example that everyone is doing machine learning would tell you, and you're going to tell to everyone later, is the example of, like, if you're having in your email, there is spam, and there is the important emails or emails that you receive. Now, how to do this? Just we are going to escape a part and then I'm going to come back, but it's just a simple example. So you are going to have emails. Some of them are okay. Some of them are considered as spam. And at the end, you are going, if you are having a new like email, we will see if it's going to be in your spam section or it's in the main section, okay, of your email. So now, given the traditional machine learning, what will happen here? We are not doing the same task. In machine learning, and given this example, we are using rules. Means me, I have a set of rules that I am applying. However, for machine learning, what will happen is that I'm using training data, which makes the difference. Okay, there is the training for learning. Okay, so for traditional programming here, in traditional programming, you would write a set of rules to classify an email as spam or not spam. For example, let's see. If any email may contain some words like free or buy now, and anything like this will make it look like a spam. So it's going to be marked as a spam. You're going to write this as a rule. It's a fact, okay? Then if the emails come from a certain domain, so you make sure that these guys are all the time annoying you. So it must be like marked as a spam for example. And so the input in this case is the content of the email, which is the words here. The input is the data you are going to see. Here, the input is going to be words, standard information, like information related to that email, okay? The program is the set of pre-trained rules that you are going to feed. And each time, like we seen in the loop, you are going to check, maybe you will update your set of rules and so on. And the output is the email is either like a spam or not a spam. So this is the case using the typical or traditional programming. Now, if we see it from a machine learning perspective, in the machine learning approach, instead of writing specific rules, you would feed the system a data set of previously labeled emails, which we see here. So here, these emails are previously labeled. And when I say there is a label, it means there is an additional information about that email. One example of the additional information, which is useful in this case, whether it is a spam or not, okay? How to get labeled data, how to label your data itself could take you many weeks. It could be an AI project or machine learning project, okay? Because in data, there is a very hard part, which is cleaning data. First of all, getting data, cleaning data, visualizing data. And there is a whole field of data engineering. So data engineering, it would be taught in different classes, okay? But let's suppose that we have the data. I know I have a set of samples, a given number of emails, on like I have the information or the mark of it's a spam or not a spam. Now the machine learning algorithms learns from this example to automatically classify future emails. It's going to be automatic thanks to the algorithm, thanks to the learning process of the algorithm that it's gathering thanks to the input training data, okay? So the output now from the traditional method, whether an email is spam or not, could serve as an input data. You see the difference between here. We are saying this is output to say each time you have an email spam or not. Now, based on if it's a spam or not, I can learn. So whenever a new email is coming, I can tell you there is a program to classify that letter, because in this particular case, we are in the context of classification problem. We go through all this like machine learning examples. So the input here is emails with labels, and the output is a model. We call it also a program somehow, but it's really a model. When we are talking about machine learning, deep learning, there is a model architecture, okay? That classify new emails as spam or not spam. So now I believe it's clear. Okay? Okay. Let's see now how to automatically update to the changes. Because if you are having data, your data is not static, which can happen at some scenarios. But given the case, for example, of an autonomous driven car, for example, what is your data in this context? For example, now we are designing a car. Yes?
Initially, it's recordings of a human driving, right?
Yes, this is a given, like, it could be an example. Yeah. The recording of a human driving could have what type of information or data, Jeremy?
What type?
Yeah, because when we talk about data, there is now a different like topic to discuss. When we say data, which is a huge topic. So if I'm talking about the recording, it could have different features, which could be
I'm not sure what you mean.
okay, what is the recording? Give me an example. Okay, I am the driver. What could be the driver recording that you may have it?
How they turn, how fast they're going, the kind of road they're on, things like that.
Okay, so in this case, you are going to have, let me say, a vector. It could be a matrix of for example, the feature, like you were saying, how far, I don't know, if I'm playing any music or not, if I'm using any, whatever features, okay? So these are the features, okay? And then for each one, I'm going to have yes or no, an answer, let me say, which is going to be, let's call it, whatever, numerical value, or this is for me, let's say Rania. This is just one sample, means one example. For each sample, you are going to have different recording, okay? So these are the recordings. Okay, we are going to have different, like, people with these, like, having different values and so on. So this is sample one. Sample two, for example, it could be the recording for call. Okay. Here, we are presenting our data as metrics, okay? For different samples, I'm answering to different questions. Now, imagine you are a car, autonomous car. So, what is the similarity? What could be the data that you can, first of all, analyze?
The type of data,
Yes.
it could be images.
Yes. So, if you are a human, you are opening your eyes. So, if I want to make a smart car, it also must open eyes, which are sensors in this case. And the sensor is a camera. And the camera is going to give me images. So, this is the first data type. Would be, I don't know, stored, let me say, CSV file or whatever. Next data type is going to be image data type. And by the way, it's between us. That image is a matrix, and it's having different, like, numerical values here, which are, Zoya last time was discussing, the RGB values and so on, okay? So, but let's say it's an image, which is having, let's say, different extension, PNG or whatever. So, the image is at each type key, I am going to take a picture of the road, and this picture is later going to be given to the machine learning algorithm. Let's suppose it's a machine learning algorithm. Otherwise, autonomous cars now are using other types of algorithms. And at each time, I'm having different data. At each time, I'm having different image, because at each time, I'm at a different position. So this dynamic of the data, because data is not always static. So this dynamic will make you need to have an up-to-date algorithm. So this is going to be used to update the machine learning algorithm. And each time you are going to update, you are going to evaluate your solution again. And if it's okay, then you are going to keep going. Otherwise, there would be an accident, the car is gone. Algorithm is crashing. Is that clear? Great. Now we are now understanding the importance of this thing. Now the machine learning can help humans as well to learn. And always you have human in the loop now in computer science, because AI is designed to help humans after all. It's not designed to be independent from humans. So, for example, even that those days I'm 60%, let's say, relying on ChatGPT. But as I was saying, ChatGPT, it's not whatever is giving we are using. I said, do not copy paste from ChatGPT to the exam. This is a big mistake that can happen ever. So, okay, use it. I'm making it available for everyone, no worries. But use your brain as well. So as a human, AI or machine learning or whatever is going to give you, based on data, each time new, like, information. And you must, each time, once you have your solution, you need to inspect the solution. It's not you blindly adapt that. And you need to understand, this must help you to understand the problem better, okay? Okay, the output of GPT, for example, is not the final output. However, it's the step towards the output. If it's not exactly the optimal solution, it's taking you to the way of the optimal solution. And I encourage using ChatGPT, okay? So, and this we will keep doing again and again and again, okay? So, this is even why we use machine learning, because we need it. We need it. It's like, we will see why. And think of it until I will be asking you this question. So, useful when? when it's useful learning, like use case. So in short, your possible use case is when?
So I was thinking like you have to be able to have good data that you can apply it later, like it's
Yes.
generalizable, I guess would be the term.
Yes. This is an accurate like example of answer possibility. It's a case scenario of when AI is useful. Any other possibility, yes, Farah?
I said to make better decisions, we learn to make.
Okay, so there is a contradiction between your answer and Zoya's answer, which is, so you are relying, or you are a person who is saying that AI is always, or machine learning is always there to give the optimal solution. But why? We cannot get the optimal solution by ourselves as human. So why, at the time that Zoya is saying it can make mistakes if it's exposed to more data? Okay, it has limitations, Zoya. We are not against, but
we're trying to make it
useful, because if you compare it to a human, it's not the same.
Yeah.
Okay.
It facilitates the tasks to the human.
Great. So this is why we were just saying that it helps human. Yeah. Even if you see the curve here, it's not all the time helping humans, but when it's good, it's helping humans. ChatGPT is not all the time serving you, but most of the time it is. Okay. So if learning is useful, and this is a fact for all the above reasons, okay, why now we are discussing machine learning? And when I say now, so means starting from a given year. It's not now, like, why it's not coming before AI? Why it's not coming like since like hundreds of years? Why it's coming at a given specific time? And why today we are studying that?
Because now we are exposed to so much data.
Yes, this is the number one. When you are talking about machine learning, you cannot do that without data. This is the key. Okay, yes?
And we have some resources where we can run our...
Yes, so we have the computational resources, because if you come back to the time of Einstein, and I don't know, the famous, why it's not coming at that time? Because they maybe all they had a paper and a pen. Okay, so now, load of available data, that's great. Increasing computational power, thank you so much. Now, the last 2 points, who wants to discuss? You can read the last word and guess. If we are talking about researchers, so we are talking about, I would say, a race. And a good thing, if we are doing this race for the good of humanity, this is a very good thing. Yeah. Now, for the good of humanity means what? It means we are contributing to the research for like addressing serious problems, and this is really good. So we have tons of available papers now produced by researchers. So this is why most of them, they are doing machine learning. Many papers are in the machine learning context. This is why now we are having more resources when it comes to knowledge. We can even develop more ideas, and this is why we are studying or doing that now, okay? Increasing support for industry. You know what? When we talk about industry, we talk about money. And if we are discussing money, and even you support that now, you are the CEO, are you going to pay any or to fund any useless research? For sure, no. Because if you are going to pay, you want at some point have a guarantee, let's say, that your money is bringing something. So if now we have all this, and machine learning is showing its power, and this is why they keep investing, okay? And this is how we can see like OpenAI solutions coming, and this is like explaining everything, okay? Let's take a moment for brainstorming. Now you are familiar with the definition of AI, or of machine learning, excuse me. So when we say machine learning with this background, what comes to your brain? What fuzzy like things that you are hearing about machine learning that you want to discuss? Or I say machine learning, what you can say, just in 2 words. You cannot give me one sentence, just 2 words. Machine learning? what your brain would say at the first like thinking. This is how we brainstorm. I would say machine learning. What comes to your brain? Just 2 words. I would accept 3. Okay. Check some for the input. I'm bringing some pen. Okay, we don't have much students. I'm bringing many papers, so I'm always optimistic. Okay.